In this video, we are going to look at the effective annual rate, EAR. When should we use it and when do we need to use it at all? I also have the financial calculator ready here on the left hand side. So let's look at the following example. Let's say we have an investor, or maybe it's just, some finance student. Let's say the student's name is Joanna, and she would like to have $10,000 in 5 years, right? So this is year 0 or today. In 1 year, in 2 years, in 3 years, in 4 years, in 5 years, she would like to have $10,000, right? 5 years in the future. And we also know that the interest rate is 6% per year. And let's say it's, what we also know that is that it's compounded semi-annually. Compounded semi-annually. And this is going to be important. Okay, so what do we need to find here? So let's say what we need to find is how much should she deposit today, right? Deposit. Just one payment, so that when it's left in the account for 5 years and it earns interest, 6% compounded semi-annually, it becomes exactly $10,000 after 5 years. So this is our problem. Okay, so how are we going to solve it? What is the true rate that the money would be earning every year? It's actually not going to be 6%, but a little bit more than that, because after the first half a year, Joanna will earn 3%, right? Half of the quoted rate of 6%. And then that amount of money will earn another remaining 3% interest over this next half a year. And so the second time that the 3% interest is earned, it's earned not only on the deposited amount of money, but also on the interest that Joanna will have after the first half a year. So the interest gets compounded 2 times within a year. And so when we reach the end of the first year, she will have more than 6% more money in her account. And this process will be repeated a few more years, right? So every year, the true rate that's earned on the money with the semi-annual compounding is more than 6%. So how much is it? And this becomes the first step in our calculations. So step 1, what is the effective annual interest rate? Effective annual rate. And the easiest way is to do it in the financial calculator. So let's turn it on. Let's do a full reset just to make sure there's nothing stored that would be used in our calculations from now on. We can also increase the decimal places because it's a 2-step problem. It's always a good idea to increase the decimal places for any intermediate calculations. Otherwise, the rounding error of our final answer will be just way too large. To do that, we press second, format. Let's change it from 2 to say 6. I press 6, enter. It's done. Now we want to calculate the effective rate. So we press second, 2, and it says interest conversion, ICONV, above the key with the number 2 in it. NOM stands for nominal. That's what's given to us, the rate that's sort of understated. It doesn't reflect all the interest on interest that's actually earned on your money. So the nominal rate, or the quoted, the stated rate, or the APR, annual percentage rate, which is how banks call it, is 6%. You put 6, enter. Then press either up or down arrow key. Stop when you see compounding per year, C over Y. The default is 1, which is interest earned, at the end of the year and no compounding in between. But this is what is now going to be changed to 2 to reflect twice per year. You press 2 and save it by pressing enter. Then again you press either the up arrow or the down arrow key. Stop when you see EFF on the display, which means effective, and press compute. And sure enough, it's a little bit more than 6%, 6.09. Okay, so the effective annual rate is 6. Let's make it blue. 6.09%, right, per year. Then we can do our second and last step. In the second step, we calculate the present value, right? How much should be deposited today so that after earning 6.09% interest per year effectively, the money grows to exactly $10,000. Okay, so we want to calculate the present value. And again, the financial calculator will definitely save us a lot of work and like a lot of parentheses and powers that would be happening if we use the formula for the present value. So let's okay, so let's again, maybe you want to clear it again. Second plus minus enter. Okay, so let's find the present value. We know that the future value is given, $10,000. Press 10,000, make it negative, and then press FV. We have 5 years, right, between how much is deposited and what it needs to grow to. That's 5N in the calculator. And the interest rate that we need to enter is not 6, but 6.09. 6.09 IY. Compute present value. So we get 7,000, right? $7,440.94. And this is the answer. Now let me show you one trick. So it turns out there's another way of doing the math, which is actually much easier. You may realize that, so we had 2 steps earlier. Now what we are gonna do now is say that okay, interest is earned every half a year. So how many times do we earn interest total over 5 years? So we do 5 times 2 per year equals 10, right? So that's how many times interest is earned. So this is like the N in the financial calculator, how many times interest is earned. Then we can also follow the same logic and say that, okay, when the interest is earned, each time the interest is earned, how much is it? What is the rate? And it's half of the annual rate. So we take 6%, divide by 2, and get 3% per half a year. And this becomes our IY in the financial calculator, right? And then we can calculate the present value, right? So for the present value, we can do it in the financial calculator. So let's reset it again. So what do we have now? The future value is 10,000. We know that, negative FV. And by how many time periods we need to discount our $10,000 is 10. So it's 10 times that the interest is earned, like 10 compounded intervals. So we press 10 N, and each time the compounding occurs, it's at 3% interest. 3 IY, compute present value. Exactly the same result. Okay, so it's again $7,440.94. See, they're exactly the same, and this is how it should be. And notice how in the second approach we didn't need to use the effective rate at all. So it's actually a lot simpler, right? You don't need that extra, formula to keep in your head so that you can do the math right. Okay. Now let's say Joanna has a friend, right? She has a friend, another finance student. His name is Ben. And he's kind of trying to solve a similar problem. Year 0, year 1, year 2, year 3, year 4, year 5. He also would like to have 10 years and 5 years. But what he is planning to do, he's planning to deposit 5 identical amounts every year. By default in finance, we assume it occurs at the end of each year. So at the end of the first year is the first deposit, then the second, third, fourth, and fifth. So these are deposits of equal amount, right? Equal amount of money. This is what we call an annuity problem, okay? So this is what we call an annuity problem. We kind of want to approach this problem the same way. So step 1, effective rate, right? So the effective rate we know is 6.09%, right? We already know it because we are assuming that Ben is also gonna deposit his 5 identical amounts of money in a similar account that pays a 6% annual interest rate with semi-annual compounding. So we know the effective rate, and now in the second step we want to calculate the deposit amount, right? The recurrent deposit amount each year. And this is basically solving for the annuity payment, right? When we know the annuity future value. So let's do it in the financial calculator. Again, let's start by clearing things. Let me do it again. 10,000 is the future value, this time of an annuity, not of a single cash flow. We have 5 deposits, so I press 5N. The interest rate in between all of them or every year is 6.09, the effective rate, IY. And we are computing PMT, right? So that's the PMT in the financial calculator. And the answer we got is $1,770.78, right? This is the deposit every single year at the end of each year, 5 times. And each of these deposits will earn interest over the correct number of years, and altogether that will add up to $10,000. Now let's do it the other way. Let's put OR again and see if we get the same answer if we do it the same way we did it earlier for Joanna's deposit. So we're basically saying that, okay, it's as if n equals 10, right? N equals 10, just like here for Joanna. It's as if the interest rate every half a year is 3%, right, per half a year, right? So 10 sort of half years, if that word exists. And then we want to calculate the PMT, right, the deposit amount. So let's do it in the calculator and see if it works. Full reset. Again, 10,000 negative is the future value. we have 10 half years, 10N. The interest rate every half a year, right? We are kind of, being consistent, so to speak here, is 3%, 3IY. Compute, just like earlier, PMT. Oops, a completely different answer. And now we're going to see why it's so different and what exactly went wrong, because something did go wrong. And, long story short, let me use this mark. This is a wrong way of doing it. You cannot use this solution when we deal with annuities, right? So this was an annuity problem. And on the left, we had like a single cash flow type problem. So what went wrong in this, alternative way of, solving the problem? Or at least you were trying to solve it differently like we did for Jan, and it didn't work. When you told the calculator that N is 10, IY is 3%, and you asked to solve for payment, the deposit amount, the way the calculator understood you is that the deposit is also occurring every half a year. And so you notice how the difference between our two solutions is roughly double, right? That's exactly what happened. But that's not what's going on with Ben's investment, right? Ben is depositing every year, once a year. There are no two deposits made every year. And so to summarize, when can we and when can we not use the effective annual rate? Actually, no, more like when can we simplify it and when can we not simplify it? We can simplify the math and avoid using the effective rate calculation whatsoever when we deal with a single cash flow. But when we have something like with a recurrent payment, like an annuity or maybe a perpetuity where it keeps going forever, then this doesn't work. You have to use the effective rate as your first step.